It is current state-of-the-art to recycle car bodies conventionally. In this process, after dismantling the interior of the car, the body is pressed into a cube, which is called compaction. In the next steps, the cubes are transported to the fractionation where they get shredded. Ferrous metals are getting separated from non-ferrous and synthetic materials, and the gained, now pure scrap metal gets transported to the steelworks. Here it gets melted down, cast into slabs and rolled into coils. These coils are then being transported to the OEM and supplier companies where they get manufactured into new car bodies. In order to save energy and thus reduce the emission of greenhouse gases, the CarE-Service project takes part in developing strategies for the remanufacturing of car bodies. The main objective is the technological development of detachable joints in body construction. These joints need to fulfill both the economic requirements of the OEM and should also enable a non-destructive dismantling of car bodies. Established detachable joints are primarily screws and bolts. Due to complex assembly, optical requirements of car bodies and high assembly costs, these screws and bolts were long ago replaced widely by welding, soldering, gluing and riveting. The only way to disassemble welded and riveted joints is by damaging the components. Now, due to the high seam quality, high connection strength, great reproducibility as well as good automatability, laser bracing is the established process in the assembly of car bodies and the automotive industry as a whole. Hard solders are being generated at joining temperatures of about 900 to 950 degrees Celsius by laser processing optics. The significantly higher melting temperature of steel at about 1600 degrees Celsius results in a process window of approximately 1200 to 1500 degrees Celsius, where the brazed seam can be liquefied and removed without significantly damaging the steel component. In order to be able to carry out this process economically, special laser processing optics were developed. A focused laser beam heats up the soldering seam to the melting temperature, while the liquefied solder gets blown out through a gas nozzle. This process is supported by the regulation of laser power in relation to the temperature. Since the processing optics are being guided by an industrial robot, the technology can be used flexibly.